he has even a haircut.
Where's your bacon shirt?
No.
It's not. Okay. Okay.
Set the expectations. Is it come with your enterprise edition?
Oh, it comes with everything. We're just talking about the Hadoop ecosystem in general, not necessarily CA, not necessarily about everything.
But then all the access control and
Everything is there. Yeah.
so if we're talking more like POSIX challenge and
We'll talk about all that.
Yeah. Good morning, everyone. My name is ATM, and I would like all your debit cards. So, that's a joke. I'm Alejandro Tucu, and actually what we're going to be talking here is about securing the Hadoop ecosystem and why security is important. If you are planning to use Hadoop or you are using Hadoop to do your real business, you need some level of security. That level of security is going to be determined by your company policies, or industry standards, and government regulations. So we're going to be first introducing a few concepts of security from a Hadoop perspective, and then we're going to go into details, and we're going to finalize with some high-level recommendations. So Hadoop is a distributed system, runs several services in a large number of nodes. Right? So all these services that whenever you're running jobs, you have even processes that are started by the cluster on your behalf to run this job. So all these processes, all these jobs and tasks, they have to interact with each other, and they do that over several protocols and as different users, service users or end users. So if you want to secure a cluster, or if you want to secure your Hadoop setup, you have to secure each one of these interactions. On top of that, if you're using Hadoop, you're not only using Hadoop. Most likely you're going to be using Hive, Pig, Oozie, Hive, Hive Metastore, etc. That means that you have yet more services to secure and more protocols also to secure. So, what's authentication? Authentication is a way to prove between two parties that you are who you say you are. You have one-way authentication. That means that whoever is in the caller initiating the call will trust the target or the service that is calling, and the target will verify the identity of this user. Or you have two-way authentication. In two-way authentication, both parties verify the identity of each other. Right? So in Hadoop, we have different type of authentication going on between different entities. We have end users to services, right? So in this case, for example, you are submitting a job to Hadoop from the command line, or you are accessing the job tracker web UI through a browser. In this case, you will be authenticated by Hadoop. You will be authenticated by Hadoop, and probably you have to provide your user and password credentials, or as we will see, some kind of Kerberos credentials to be able to access to the server. Then you have service-to-service authentication also taking place. Like Hadoop, as I mentioned, is several services. For example, you have the job tracker and the name node, that they talk with each other. In this case, typically the job tracker initiates conversation with the name node. In this case, we have a service-to-service communication, and in this case, we need some kind of service credentials. They have to somehow they have to prove to each other who they are. Right? Then we have a third type of communication, is services to services on behalf of a user. For example, if you are using Oozie to submit a job to the cluster, you, as a user, you will authenticate against Oozie. Then Oozie will authenticate against Hadoop, and at that point, Oozie will tell Hadoop, I want to run something on behalf of this user. So besides the user to Oozie authentication and the Oozie to Hadoop authentication, you have also a trust relationship between Oozie and Hadoop where Hadoop will trust Oozie saying, okay, Oozie is allowed to job on behalf of this user. And you can have multiple of these hubs. You could be using even Hue in front of Oozie. So a user will authenticate to Hue, then Hue will authenticate itself to Oozie, say this is on behalf of user foo, and then Oozie will authenticate to Hadoop and say this is on behalf of user foo. Right? So you have this trust relation that you have to configure. And finally, you have task to services authentication. Whenever you submit a job to Hadoop, multiple tasks, multiple processes start running randomly in the cluster. At this point, all these processes, they will access data in HDFS, and that has to be done in an authenticated manner. So for that, we have something that is called a job token. Whenever you submit a job to Hadoop, like the client that is submitting the job to Hadoop, gets a special token and somehow propagates this token to each one of the tasks that are running in the cluster. And then these tasks, when they want to access HDFS, they just present this token that is valid for the duration of the job, and they can access data in HDFS. You can think this token as it would be like an HTTP cookie that somehow you take it from a browser, you give it away, and then you can, so whoever has that cookie can access data on your behalf. Right? So that is on authentication. Then we go to authorization. Depending on the service that we are talking about, for example, if it's a storage service, you want to protect who can access your data. Like in the case of HDFS, who can read or write files in HDFS. In the case of HBase, could be who can access a particular table, etc. If we are talking about the processing service like Oozie or Hadoop or MapReduce Hadoop, you submit jobs. So by authorization, you can determine who can submit jobs, who can view and manage those jobs. If you are talking about Impala, who can submit queries to the cluster, right? And of course, you have also the concept of queues. Depending to which queues you have authorization, you can use one of those queues to submit the jobs. Then we have, wrong button. So then we have confidentiality. Even if we have authorization, if somebody is snooping on the network or somehow gets hold of your data, they can see your data. So sometimes you need something stronger than authorization. In that case, you need to protect your data from anybody to see it unless they have the right keys or right credentials. So what you normally do for these things, you use encryption. And you have two things that you have to care about. One is protecting the data at rest, the data that is sitting on the disk, like while nobody's using it. And the other thing is protecting the data that is on the network. Remember, Hadoop is a very large distributed system. Most of the data goes through the network at some point. You need to protect that if you care about confidentiality. And finally, we have auditing. Like auditing allows you to trace who did what and when. Right? In the case of data, who read this file or read this table, or who wrote in this table. In the case of jobs, who submitted the job, who managed the job, or who viewed the jobs. So these are kind of like the basic concepts, and now ATM will continue with more details.
All right, thanks a lot, Tuku. Yeah, so my name is ATM. I'm going to talk to you a little bit about how some of the concepts that Tuku just talked about are implemented in Hadoop. We're going to talk about some integration recommendations, some secure Hadoop deployment recommendations. So in Hadoop, we have the three types of authentication that Tuku just talked about. Typically, you'll have, perhaps the most obvious is you'll have end users authenticating to the cluster. This is usually via CLI, like you're typing HDFS LS, or libraries that your program is written that are interacting with Hadoop, et cetera. Those are usually going to get their credentials by a user typing KInit, typing in their username and password, or via a key tab. The other way that users typically interact with Hadoop is via the web UIs. We're going to go into more detail in this later, but there's several different ways that you can authenticate to the web UIs, assuming that you want to allow authentication to the Hadoop web UIs at all. The second sort of authentication, the details there, is services to services. This is, in Hadoop, something like intra-cluster communication to make the whole thing work at all. Data nodes need to communicate with name nodes. Task trackers need to communicate with job trackers, that sort of thing. And that all needs to be authenticated as well. Again, there, the typical way that credentials are deployed there is via Kerberos key tabs. And then finally, services to services. So in Hadoop, the example there that perhaps the most obvious example is something like the Oozie server, which is running a workflow on behalf of a user. It was scheduled a long time ago by that user, and now it's about to be run. And that workflow needs to submit jobs as that user. So what you do is you configure the Oozie server to be what's called a ProxyUser, which is capable of, once authenticated as Oozie, it allows that Oozie user to act on behalf of other users in the cluster. So authorization details. So this is just a list of the sort of authorization mechanisms that exist in a typical Hadoop deployment. In general, anything in Hadoop, of which there are several different things, that stores data are going to have ACLs or Unix-style permissions to protect that data. So these are things like HDFS, which has typical Unix-style RWX user group other permissions, HBase, the Hive metastore, Zookeeper, etc., which store data. They all have ACLs, and these are based on users and groups, and can again specify read, write, and maybe other sort of project-specific permissions. In general, anything in Hadoop that is capable of running a job or a workflow or a task or something will have ACLs as well to determine who's authorized to submit to certain queues, who's authorized to submit jobs with certain priority levels, etc. And the examples here are the job tracker, the resource manager, that's like job queues, or the Oozie server, which can have separate queues. So confidentiality details. This is again a list of the confidentiality options, the encryption options that exist in Hadoop or don't exist in Hadoop natively. In general, Hadoop has pretty good support for encryption on the wire. There's a lot of protocols running around in a Hadoop cluster. Tuku talked about this is a big distributed network system. Lots of protocols get used, various types of RPC, custom Hadoop protocols, HTTP in various places, etc. For the most part, these can all support different types of encryption. In the case of Hadoop RPC, it uses SASL. You can configure the quality of protection, it's called, for Hadoop RPC, and you can, by default, it's set to authentication. You could set it to confidentiality. Similarly, HDFS data uses a SASL-style protocol, and you can set the quality of protection there to confidentiality. HTTP is used all over the place. For example, obviously in the web UIs, that's over HTTP, but also perhaps less obviously in MapReduce Shuffle, when maps have completed their work and need to send that data out to reducers. That authentication is done by HTTP, and that supports SSL, which supports confidentiality. There's a few things in Hadoop which I mean, there's no fundamental reason that they don't, but they just, at the moment, do not support network encryption. And that's things like the Hive metastore RPCs to that. Impala, though it uses Thrift SASL, which ostensibly supports confidentiality, it's not implemented there. For data at rest, there's no built-in support in Hadoop. This is protecting against the sort of attack where, like, say, a cluster administrator who's nefarious reaches into a box and pulls out hard drives and walks home with them, that sort of thing. The things that I've heard of people doing, some folks have used Hadoop's codec support. So usually these are for compression. It's effectively a little filter that you put in place to take your data and transform it a little bit before it's written out. Usually that's compression. There's no reason it couldn't be encryption. It's sort of left as an exercise to the user how you want to manage keys, how you want to distribute those, et cetera. It's really not a fully baked system, but I have heard of customers doing that, users doing this for applications that really need it. The more common thing that I've seen is folks encrypting the underlying local file system. So HDFS does not write directly to disks. HDFS writes to an underlying Linux file system. And there's lots of solutions that have existed for many years that are capable of encrypting that. Perhaps the most common one that I see in the field is something called Gazang, which has built-in support for Linux file systems to encrypt all the data that's written to them. Auditing. Auditing is kind of a mixed bag as it's currently implemented in Hadoop. Certain projects and certain services have really robust auditing things. HDFS, for example, has a specific audit log. The name node will write out an entry for every single metadata interaction. That's a read or a write or a list of a directory or a make directory, that sort of thing. It will write out when it happened, what user did it, what permissions were set on it, etc. Things like the job tracker, the resource manager, job history server would allow you to piece together, it's not a dedicated audit log, but they would allow you to piece together all the jobs that were ever submitted. Who did that, what queue they were submitted to, what ACLs were used, etc. Again, that's sort of not intended for the purposes of auditing, but that is what it's effectively capable of. Oozie, like HDFS, has a very dedicated audit log. You could plug in your own audit logging plugin, or by default, just write it to a file. It goes into a separate file. And that contains audit logs of every user request, managing workflows, submitting workflows, deleting workflows, all of that sort of stuff. As I've mentioned a little bit, there's a fair amount of gaps in the auditing story of Hadoop. Not all projects have explicit audit logs. For example, Impala has no real central service that gets a log of every query, or that clients connect to for any given query. All the Impala Ds in a cluster themselves will log what queries are run, and you could aggregate those logs and produce effectively an audit log, but that's not done by default. It's also relatively difficult, or perhaps impossible, to correlate jobs or workflows or that sort of thing to their lower level constituent pieces. For example, here you run a Hive query. A Hive query often will consist almost always of at least one MapReduce job, maybe several. Tying back the complete set of MapReduce jobs that were a Hive query is difficult or impossible. Maybe it's doable because Hive will insert little pieces of metadata effectively in job configs, and you can sort of piece that together. But there's no way of doing this by just looking at the job history and saying, oh, this job was part of this Hive query, for example. Or, perhaps more obviously, a MapReduce job gets run as some user. All of the things that MapReduce job does show up in the HDFS audit log, but if you were to look at the HDFS audit log, there'd be no way to say, oh, this was an access from this MapReduce job. There's no way to go backwards. So Kerberos. This is beginning the portion of the talk where we talk about integration with existing IT systems. And perhaps the most obvious thing that you will have to integrate with when you deploy secure Hadoop is some Kerberos system. In general, what's going to happen here is that every service in a Hadoop cluster is going to need its own principal. And by service, I mean on a single node running a daemon. So on any given slave box, let's say it runs a data node, it runs a task tracker, it might run an Impala D. Each one of those is going to need its own service principal. This sort of balloons the number of service principals that exist. In a 1,000 node cluster, you're probably going to have at least 3,000 extra principals. This might be, perhaps obviously, annoying for a corporate IT team that's managing a big central Active Directory server that's primarily used for user principals. So perhaps the solution that comes to mind is, okay, I'll run a KDC or an Active Directory server just for the cluster. Of course, the problem with that is users don't want to have duplicate accounts. You don't want ATM to have both his central account and his Hadoop account. The solution here is to separate those two concerns into separate KDCs. That means run a local to the cluster KDC that contains all your service principals, HDFS, MapReduce, et cetera, for all the nodes in the cluster, and a central Active Directory server that contains ATM, Tuku, et cetera, and set up a one-way trust, a one-way cross-realm trust between those. And I'll show a diagram in a slide or two that perhaps makes this more clear. But the point there is that the central IT team doesn't need to concern itself with Hadoop principles, and the Hadoop operations team doesn't need to concern itself with user principles. So groups. Another place where where you'd really like to integrate with existing IT infrastructure is going to be groups. Most of Hadoop authorization is based on users and what groups those users belong to. For example, I might belong to analysts, eng, marketing, or something like that. And that's all in the corporate Active Directory or LDAP system. Hadoop doesn't have a separate database of groups. There's no need to set up a replication or anything like that. At the time that a Hadoop master service, like the name node or the job tracker, Oozie server, et cetera, wants to determine what groups a user is in, it will call out to some external system. So it doesn't look at its own database, it calls out to some external system. Now what that is highly configurable. There's a few default options. It's also plugin based. So if you have some site-specific group service, you could write your own thing for that. The ones that exist by default are the shell-based mapping, which literally, when the name node or other service wants to determine the groups that a user is a member of, it forks and shells out and runs a command to determine the group membership. Also options JNI based, where the name node or the job tracker will call the appropriate system call via JNI, so no forking, it's a little bit faster, et cetera, to determine what groups you're a member of. Another option that ships by default, LDAP group mapping, where no system call, no shell command. If your groups for your users are stored in LDAP, the name node of the job tracker will connect directly to that LDAP server and run a query there to determine the group membership for a user. So here's a diagram of what both of those things look like. The Hadoop cluster is the big pink thing. Your local KDC is the green thing. Local KDC, this is for the cross-realm trust. Local KDC will contain all of your service principals, HDFS, Yarn, MapReduce, Hive, et cetera. That will be managed by the local Hadoop ops team. That will be a separate realm. In this case, I put hadoop.example.com. The blue box is your central Active Directory server, probably already contains entries for all your users, Tuku, ATM, et cetera. And that will continue to be managed by the IT team, by your central corporate IT team. You set up this cross-realm trust so that a user's credentials will work in the Hadoop cluster. ATM doesn't need a separate account. I use my normal credentials, and I can already talk directly to the Hadoop cluster. The thing at the top is the group mapping. In this case, I said it was the LDAP group mapping. So Active Directory is both a Kerberos KDC and an LDAP server that contains groups, et cetera. So you can configure separately from the cross-realm trust, they're just separate concerns. You can configure your group mapping to talk directly to the Active Directory to determine what groups a user is a member of, such as ATM. So web interfaces. The other way of interacting with a Hadoop server or a Hadoop cluster besides RPC is through the web interface. There's a lot of web interfaces running around. For example, perhaps most people are familiar with the name node web interface. The job tracker has a nice little web interface. The RM has a lovely web interface. The Oozie server has a very capable web interface, et cetera. Hue is another great example of a web interface that is expressly for interacting with various functions of a Hadoop cluster. Naturally, you'll want to set up authentication to these web interfaces, and there's a lot of different ways to do that. By default, Hadoop ships with what's called Spinago. That is an HTTP authentication protocol. There's client and server implementations of it in Hadoop. It's used for intra-cluster authentication that goes over HTTP. It's also a standard that most web browsers support. So if you configure Spinego on your named node web UI, most browsers that exist, Firefox, Internet Explorer, et cetera, can connect directly to that and use your local credentials with a little client-side configuration to authenticate to that web interface. Hadoop components which use servlets for their web interface authentication, which is most of them, you can plug in any arbitrary servlet filter. And Spinego is the one I just talked about. That is implemented as a servlet filter. But you could put in your own site-specific SSO solution. You could put in various servlet filters that ship with standard SSO deployments. So now we're going to talk about some deployment recommendations. These are high level. We should have a few minutes for questions at the end. I'm happy to answer any more questions we have about deployment recommendations, but these are the obvious ones. The first is that deploying all this stuff that we've talked about today is kind of a pain, and it can all be deployed piecemeal in the sense that if all you really need is secure HDFS, you could deploy only that. If all you really need is secure MapReduce on top of HDFS, you could deploy that. You don't have to enable all these web interface authentication systems. You don't have to turn on all the encryption options, et cetera. If all you need is sort of edge security, if your goal is to have a Hadoop cluster and keep out most of the company, but anyone who's able to access the Hadoop cluster is a single group, and those group users all trust each other, then go ahead and set up some sort of edge security. You could do that with like Oozie, HttpFS, et cetera. So only deploy what you need. The second deployment recommendation is when you're going about setting up a secure Hadoop deployment, to sort of start with first principles, go iteratively. That means when you're first starting out, just set up secure HDFS. Make sure that's working before you sort of go whole hog and set up secure everything, configure secure Oozie and this and that, and then turn it on and say nothing works. Set up secure HDFS. Get your name node working. You should have to type K-init before you run Hadoop FSLS. Make sure that checkpointing is working in HDFS. I put that in separately because it's easy for an HDFS cluster to appear it's working, but in fact checkpointing is not, which means it's not going to work for long. Start up your job tracker. Job tracker needs to write to HDFS, so if you have any of that misconfigured, then that won't work. After you start up your job tracker, get your task trackers started. Task trackers, I put that in separately because they have a little extra piece of inner workings called the Linux task controller that's sort of notoriously finicky, let's say, with its configs. Once you have all that working, configure the Hadoop web UI authentication if you want that. Now, and I do say if you want that. Minute you turn on security, certain Hadoop web interfaces will require authentication. Some will not. For example, the name node overview web page, which lists like how much space is left on the cluster, doesn't require authentication. There's no sensitive information there. And if that's all you need, then maybe you don't need to enable web interface authentication. After that, get your monitoring working again with security. And this is an important one. Some people forget this when they're planning their secure Hadoop deployment. When you flip on security, certain things like, say, metrics, JMX, et cetera, will suddenly require authentication. And if your monitoring tools aren't capable of dealing with that, they'll just stop working. Once you're done getting all of that set up, it's time to start up the services, the sort of the second turtle, if HDFS and MapReduce are the bottom turtle. Get HBase running on top of that, get Oozie, get the Hive metastore running, et cetera. And do this piecemeal, make sure it all works before moving on to the next step. It's strongly recommended that you use some sort of admin or management tool. These things are generally capable of managing the local KDC that I talked about as being a deployment recommendation, creating service principals, deploying key tabs, et cetera. All of these configs that I've talked about here can't really be rolled out. They can't be deployed via rolling upgrades. You need everything to match up on this side and that side before anything will work. And there's a number of management tools out there. It's desirable to use them. And that's it. We have about 10 minutes for questions. If you have any questions for me or Tuku, please step up to the mic and we'd be happy to answer them. Mic over there.
So one issue with Kerberos is ticket lifetime, ticket expiration. Do you guys have recommendations on what sort of ticket lifetimes for users?
Yeah, sure. So the question is, one issue with Kerberos that you need to set a ticket lifetime. Do we have a recommendation for what sort of ticket lifetime to set for users? I would say just nothing too short, and too short is kind of up to you. The default is something like 10 or 12 hours, and that's a totally reasonable thing to do. It doesn't actually matter for the service principals what it is, because they'll, as long as it's like north of 10 minutes, because they'll renew their credentials from their key tabs. So just, you know, it needs to be not 5 seconds or something like that. But for batch jobs. Okay, so I misunderstood the question. The point there is batch jobs might take many hours to run. Your Kerberos ticket could expire during that time. That's actually not a problem with the way that Hadoop's designed. You need to authenticate with your Kerberos ticket when you're initially submitting a job, but at that point, Hadoop will start using delegation tokens, which is an internal concept to Hadoop. And that is what the credentials that will be used by all the tasks that constitute that job. And those can be renewed totally, they have nothing to do with Kerberos. They'll be renewed independently of your Kerberos ticket by the thing that's managing the job. So for the job tracker will renew delegation tokens ad infinitum for you. Great.
You mentioned that you can enable security like piecemeal based on the component. So if you enable security for HDFS, how it's going to work with non-enabled security on job tracker, task tracker, or anything else?
Yeah, sure. I mean, in general, this is sort of a what threat model are you concerned about here? I wouldn't, if you're running MapReduce on top of secure HDFS, you're sort of fundamentally insecure in some sense. So you should turn on secure MapReduce there. But for example, if what you were really concerned about was like authenticating to HBase, and that needed to be done from external systems, that sort of thing. You could turn on security on HBase and HDFS, but not necessarily security on MapReduce, and that might be acceptable in your deployment model. I mean, it's, you know, sort of that's sort of up to you, up to the specific challenges that you're dealing with. But you're right in general that you need to secure everything that's below you, and that if you're running anything high level that's not secure, that's obviously insecure.
No, the question here, like for example, if you have HBase and MapReduce and they're running in the same cluster, and suppose I say, okay, I need secure HBase, but I don't need to secure MapReduce. If you're securing HDFS, then MapReduce cannot even access non-securely to secure HDFS, correct?
Oh, I see your point. You could set it up such that MapReduce could access secure HDFS and not require authentication itself. Not a whole lot of reason to want to do that, but you certainly could. For example, in CDH3, HBase supported interacting with a secure HDFS cluster, but didn't actually support security itself. So I mean, that's like a trade-off you could make. Do we have a question over there? No. All right.
Hi. Thanks for the thorough treatment and review of all the security.
Happy to do it.
One thing I was just thinking about as you were going through that is, you know, I talked to a lot of large enterprises that are dealing with this situation, and one thing they do is take a step back and say, what is the data that I want to protect? Because in a lot of cases, they're able to eliminate certain things. Or, you know, do I need to bring in data that contains social security numbers into my Hadoop cluster? Maybe not. Maybe I can eliminate that before it goes in, or I can de-identify that mask,
tokenize it or something
encrypt
like
it. And so I think that's going to affect how you prioritize, you know, doing that long list of things that you presented to secure your cluster. That might change. Taking a look at your data and what you need to secure.
Certainly.
Curious if you've seen customers taking that approach.
We've seen it. There's not a lot of great support for it, as you know. I would have mentioned it if it were. The sort of thing that we see is exactly what you described, which is if a company has like really important, if it has components of its data that need to have higher levels of protection than the rest, they just don't put it in Hadoop. That's not a good answer, and that's something that we'd like to improve. If you have thoughts and requirements there, I'd encourage you to come to the there's a security design discussion that some of the Hadoop contributors are having later today. I'd encourage you to come to that, talk about that. That's definitely the sort of feature that just has been ignored up to this point and is becoming increasingly important.
Hey, my question is kind of a follow-up to what was just said. So we have some data that we'd like to control access to and maybe encrypt, but obviously most of that data doesn't fall in that bucket.
Yep.
All that data is already on HDFS, so I was kind of curious as to what your recommendations were.
Yeah, so I mean, encrypting portions of your data, there's just no support for that at the moment. Restricting access to portions of your data, that's, depending upon what exact tools you're using to analyze it, that can already exist, and it's getting better. That sort of finer-grained authorization support is getting better all the time. For example, Hive Server 2, one of the main goals is supporting finer-grained authorization decisions on, say, column level, that sort of stuff. And that's coming down the pipe in like a few weeks or something like that. But at the moment, again, it depends upon what exact tools you're using to protect that stuff, what file formats you're using even.
It's largely just kind of using Unix permissions, the best way to control users.
At the moment, pretty much the best thing you can do is Unix permissions, which are file level effectively, which isn't necessarily the most fine-grained thing. Of course, it depends upon how you serialize it. If you serialize every column as a separate file, maybe that can make sense.
All right, cool, thanks.
Yep. Question over there?
Hi, I had a question on the SSL part of the, you had a slide where you talked about SSL certificates and so on.
SSL or O?
Yes, SSL. Right,
Oh.
so could you, I didn't get that part and it was not there in the deployment slide afterwards, so.
You're asking, just to clarify, are you asking about, say, encryption of the MapReduce shuffle and where the SSL certificates are, that sort of thing?
Okay, so if you want to do encryption on HDFS for the shuffle, you will have to deploy certificates, certificates in all the task trackers or node managers for the shuffle service. And if you don't have a certificate authority, you will have to deploy also the public keys in the node, so whenever the reducer tasks are fetching data, they recognize the certificate.
I see. And any reason why couldn't the job token be used for it or the shuffle token?
Sorry?
Any reason why the shuffle token couldn't be used for it?
The shuffle token.
Why the?
Why couldn't
the job token that is, that is there.
I'm sorry, I'm not understanding. I'm deaf.
Why couldn't the job token be used?
Actually, that's something that so when I was doing the shuffle, I play around, and actually what I did is I was creating a certificate using the job token as the seed, right? So by doing that, I could create the same, the corresponding client certificate, because I have the job token in both sides, right? In the task tracker or in the node manager that is doing the shuffle service, and I have that also on the reducer side. I have so I was using that job token to create both the server certificate and the public certificate. But the problem is whenever you're creating an SSL certificate, there is a random factor. So if you create twice an SSL certificate with the same organization, all the same information, there is a timestamp and random value a factor in it, so they are different. So what I was doing, I hack a bit things around to make sure that that random thing is the same in both. Right, but the problem is that that's defeating the purpose of an SSL certificate, right? So it would make it weaker, predictable, right? So that's why actually we went on this path. Okay, we require creating the certificates beforehand. One of the things I've been thinking that would be a way to do it is actually to that could, for example, when the task tracker or the node manager comes up, they could, as part of the handshake, when they are registering with the job tracker or the resource manager, the resource manager could create the certificate for the task tracker or for the node manager, and then use that as and then if you're using a certificate authority installing all the cluster, then you are all set. And by doing that, you could remove the need to create all the certificates beforehand.
All right, cool. Thanks.
I got a couple of questions. So in one of the slides, you mentioned that none of the groups in Kerberos have to exist on any Hadoop nodes.
Sorry, say that again?
in one of the slides you mentioned that the groups or the roles that are in the Kerberos, rather the KDC, they don't have to exist in the Hadoop node.
That's
Does
correct.
that mean all the users have to exist though?
Yeah, that's a good point. So the question is, I mentioned that the groups don't have to exist on all of the Hadoop slave nodes, but the question is, does that imply that the users do? And the answer is yes.
And does that mean on all Hadoop nodes?
On all the slave nodes where you run tasks. The tasks that run as the user, like the Unix user account of the user who submitted it, we do that for isolation purposes, which means that yes, you need to have those user accounts on all the nodes.
So
It's a point of integration that I should have mentioned, probably desirable to set up PAM on all of the slave nodes so that those user accounts exist by default.
So who is responsible for creating those users?
I mean, whomever deploys secure Hadoop.
So when you add a new node and Hadoop stack gets installed on that node, it's not necessarily that those users will be created by Hadoop, right?
That's correct. I mean, there's nothing in Hadoop that's going to create those users.
So you have to use some kind of provisioning software to make sure that you have all the users available in all the nodes of the cluster.
Yeah.
So a follow-up question on that though. So in Oozie you mentioned that it uses this ProxyUser to submit the job, right?
Yeah.
So if I understand correctly, Kerberos allows you to get a ticket as a different user than what you are logged in as a local user, right?
So Kerberos does sort of have support for that, but that's not, the ProxyUser thing is not a
I know. So
Kerberos
the
feature.
question is like, is Oozie thing bypassing the Kerberos thing altogether? Or?
No, I mean, the Oozie thing is authenticating using Kerberos, and then it's using a Hadoop specific concept called the ProxyUser to sort of sudo as another user.
So we are not using
So is that
ticket chaining.
Is that a Oozie specific thing or can a
No, it's a
third party?
Hadoop specific thing. Anything could do it. The Hive server does it too.
But is it explicit support for Oozie or can third party application vendors can write Oozie like applications to do that?
You absolutely could do that. Yeah, there's like instructions on how to use the ProxyUser API. We're out of time. I'm super sorry I didn't get to your questions. I'll be out in the hall if anyone wants to come up and talk. Thanks a lot.